Hi, my name is MinHsuan Peng. I'm in the visualization team in Wolfram. This year, we'll talk about the overview of labeling function in Mathematica. Hello, everyone. Welcome to my session. My name is Min, and I'm a member of the visualization team here in Wolfram. So today would be my third time giving a talk about labeling system in visualization. So that was my original title, Automatic Labeling in Visualization. And I decided to add an overview on top of this because there are actually a lot of things to talk about, and I just want to pick an angle for this. So I would like to kind of introduce you to the visualization, the labeling in the visualization with these 5 W's. So first thing is that where are the automatic labeling used, and then why we are doing the automation at all, and then what are automated, and then we'll talk about how they are automated. That's a big question mark, so I will give you some flavor of it, but we won't go to the detail. And then when were these features rolled out in the sense of the versions? Right, so here I'm trying to build a case for you that why we are doing all this. So I just found some examples from the Mathematica or the Wolfram language, and also from the internet. If I can open this. Right, that's the problem of having too optimized. Right, so this is just an example from the geographics. This is a map. Map is probably one of the many applications that labeling is heavily used. And we actually didn't label the cities or the country names in the Wolfram technology. This is just straight from whatever the map source we have. But I'm trying to show you that, why we are doing this again. And also here is an example from the internet. It is a map, and this map has a mixed type of labels. One is just direct labeling, and we also can see the callouts, and there are also the substitutes in the legends for the smaller areas. Another example is from the GIS. There are points and some information that's interested for the creator. So these are all the applications related to the map. Another example is the star chart, which, if I can open this. This is from the Wolfram Alpha. This is another type of applications. That is, you have many points in the vicinity, but you don't actually label all of them. You only label some features. In this case, it will be the brightest stars. Or on data analysis, this is just a random pie chart I found on the internet, and you can see the labels, the callouts, or this line plot. The labels are put directly on top of the curve. Another type is in the diagrams. In this case, is anatomy. No matter is the human or the dog that we supported in this version, the labels are crucial to understand or to have more information for them to be useful. So those are just some flavors of the applications, why we are doing that, and then why we are doing the automation at all. Mostly because the freehand labeling is very time-consuming and very hard to reproduce. Especially in the Wolfram language, all the labels we are doing can distill down to the text, which is a flavor of an inset. And so that's what you essentially have to do, and what I essentially have to do to put the labels in the graphics. And if you have a set of points that you want to label, then you will have to know the syntax of the text. And then without any algorithm running, it's as long as the points started to gather together or it's packed, then it's destined to have some labels running into each other. So the automation here would be the goal. The goal is to try to find the labels, positions for them so that they don't run into each other. With all that said, how many times have you created your own visualizations with graphics? So most of them use the visualization functions in Mathematica or Wolfram language with these high-level visualization functions like the plot, list plot, etc. So if you want to add labels in these visualizations, you would have to use prolog, prelog, or you have to understand how to use the show and construct your own graphics. And like in this case, I had to go through some iterations to put the labels there for them to make sense. So it would be really nice if we have just some automatic way to put the labels. And the last point I want to bring up is that if you have some very dense information that you want to show in the visualization, labeling can quickly become the main task for you to create a visualization. Just imagine that if there's no any automations going on, how you are going to put the labels for this plot to show off the data. The time you spend on the labeling will be just out of proportion. So I hope I've convinced you that there is a case here. And so now I want to talk about that, what are automated in the Wolfram language. We have done a lot of special cases for different scenarios. So I'm just trying to find some very representative examples to tell you that what we have done. So the first type is a line labeling. Typical plot, if you have multiple curves, and all you need to do is put the plot labels, go to automatic, then the function names will be picked up and put it on the right-hand side of the curves, or the end of the curves. And then the automation here is that they are positioned so that they don't run into each other. Semi-automations, so there are cases that you want to put the labels inside the plot and just to point to some features of the function. And all you need to do is just specify the leader position. Here I only specify the x position, which is pi, and the y position is automatically computed here. And I want to make the case here is that these two plots, the difference is the right one has a higher frequency, so the labels is automatically adjusted, so it doesn't run into the curve. So, but the syntax is the same. Or you can give some named place, like above, below, such kind, and this is going to be automatically placed. So I have some bonus examples for you to explore. Right, and so that was the line labeling. So by the way, that is just for the plot I took for the examples. All the functional curve labelings are in the same fashion we have supported. And the 2D and 3D points labeling. The 2D point labeling is probably the first automated labeling problem we have tackled in the years. So here is just 50 random points and point to 50 random words. And you can see that the algorithm is placing the labels in a way that they don't run into each other. And here I want to show off that these three plots are just the normal distribution with different standard deviation. so the points are kind of scattered or very dense in the center area, I fix the plot range to make my point that when there are more space to put the labels so they don't run into each other and the points, then you can see more labels. This is all done automatically. Another example is in feature space plot, which is also point labeling. I want to tell you that the labels, this is Wolfram language. You can put any expressions as the label. Here is image. And we also introduced options called labeling size in probably 11.3. Because if your label is image, sometimes you may want to decrease the size or increase the size of the image. And then correspondingly, you get a different dense of information or labels. We do the same thing for the 3D points. This is this point plot 3D. So the same fashion, and it just works like that. I want to mention that this avoidance is only for the current viewpoint. So once I start to rotate it, the label will stay put. Another something bonus for you to explore. And the next one is the parametric curve. So when we developed the labeling for the curve, we quickly realized that parametric curve is a different beast. So this has been supported since in this version, version 12. Here is a 3 curves, parametric curves. They don't overlap. So the labels are automatically put in the fashion that they don't run into each other, nor running into the axis. This is another example, which should have been 3 to begin with. The previous example, the 3 curves didn't overlap, but these 2 curves overlap. So I just want to show the functionality here that the labels are able to find the position so that they don't run into each other and they are not ambiguous. And right, so this is my intention to increase the petals of that blue curves. You can see that we successfully found another position, so it is nicely labeled. Right, so semi-automations for parametric curve is that you can also specify where you want to put the labels in a very easy way. So I'm just using fold to create a nested callout. So this is the label, and this is the label position, which is just the U value, the parameters value. The same thing, we also extended to parametric plus 3D. And of course, the point is that so that the labels don't run into the curve. Yes. So if you don't specify viewpoint, they will give you the default viewpoint, and the labels is placed so it doesn't run to the curve. And if you rotate it, it will run to the curve for sure. But if you specify the viewpoint in the input, in the options, then it will run the algorithm based on that viewpoints, yes. The next one is the region labeling. Parametric plot, when you specify 2 variables, then it will create a region. The algorithm is used here to place the label as well. And this is a bit boring, it's just one region. All right, I will get to the point. But here, you can also specify the XY position in the plot, and the leader is going to just point to the closest point on the boundary. So you may ask that what if I put the labels inside the region? Yes, they will not show a leader for you. So it will just be in the region. And in this case that we have multiple regions, the automation done here is that, again, it doesn't run into each other and is pointing to the region, so it's not ambiguous. The same thing extended to the region plot. And here, this is a good case to show you that if we, in this case, there's no good point to put two labels on the right-hand side without any ambiguity. So you can just tell the call-out positions, one put before, one put the after. So that's that. And then in the version 12, we also have the surface labeling for the plot 3D. The automatic position for here is just on top of the plot. And you can also specify the XY position. The Z position will be calculated. And the leader will point to the surface based on the normal of that point. And this is just not for plot 3D. We have done this for the revolution plot 3D and spherical plot. So the last category is the labeling in the charting system. We have the labeling for charting since version 7, and along the way we have updated it. And the automations here is that the labels are layered in a way that they don't run into each other. And this is all, algorithmically wrong. So if I reevaluate this will be, different. And you can also put the labels. If you don't say they want to put it in the callout, by default, it's going to put it in the axis. This looks terrible because the text, we preserve the size of text intentionally. But with these new options, you can specify the labeling size for that. This may not be the best example to show of labeling size. But if your label is actually images, and this is the same plot, the only difference here is the image size, right? So on the left-hand side is 200, and the right-hand side is 400. And you can see that without any further specification, the image label are resized automatically based on the bar size. We also done some automations for pie charts labeling. It has been an issue for the pie chart labeling because when the pie is very small, those crowded labels will run into each other. And now we have done the way so that it will kind of like spaced out, very similar to the plot. We have done this for the bubble chart as well. Since I'm running out of time, so I'm just continue. And so I want to talk about how we did this. There are a few methods we have implemented. The first one is image processing tools that we have used under the hook. This has been done, so this is other plots we have seen before. So the image processing is used in the line labeling, and the tools we use is like the basic image operations, open, close, erosion, dilation. And we also use that on the parametric curves. So what we did here is that we used the image processing to leave out the intersections, and we only consider points that not intersect. Optimization, we use find minimum to solve the problem like in the multiple curves and also the pie chart labeling. So the constraints is just like, so the labels don't run into each other and all the labels needs to be resided in the plot range. And we also use computational geometry functionalities to calculate where the positions should be in the region case. And then this is the point feature labeling problem algorithm we have used. So this algorithm is the one that run to this point labeling. So they are choosing the positions so they don't run to each other. Yes. And there are some other algorithms we have used or developing in-house. Like the Plus 3D, this is a difficult problem, so we have to be creative. So this is the one we use the service normal trying to do that. This is still the first cut. We are trying to improve it along the way. And we also have the timeline plot and bar chart. They are on their own in terms of automations. I will see more examples there. I want to talk about the label visibility. We introduced it in version 12. This is an option that we realized that we really need these along the way. That is, so we have a final control to say that when do we want to see the labels no matter what. And this is just straight copy from documentation. Right, and so these are two examples here. I think it makes the point. That is that if you say that label visibility going to all, then you are going to show the labels no matter what, even if it's running into other labels. And if you say that every label has infinity priority or visibility, they will try their best, but not running into each other. Right. So the last thing I want to mention is that all these algorithms are based on some factors, of course, the size of the labels, and also the size of the image, and also the plot range. So if you set the image size differently, then you will get more labels. Right. So when were these functions rolled out? So I made a timeline plot for these. So at version 7, we had the chart labeling function, and that was the introduction for the charting functions. And version 8, when we had the financial charts, we have event labels. And here we did something different. So, and then we have timeline plot in version 10. Then we introduced plot labels in version 10.4. That's the time we have the automation started. So we updated the labeled, and we updated all the labeling functions and the plot labels in sets of the plots. And we introduced the callout. That makes another update. And then we introduced the labeling size in 11.3. At that point, we included feature space plot, 3D version, and this point plot 3D. And in this coming version, the data is just made up, don't quote me. So we have label visibility, and we did another update for all the vis functions. And we kind of integrated the label with callout internally. You may not notice, but I know that. And then we added a lot of support for parametric plot, polar plot, all these plots. And if you are familiar with Wolfram language, this is actually probably 30% or 40% of all the vis functions. Our plan is that we will gradually roll out the functionalities to all the visualization functions, which are not just done by our team. So we are working on that with all the developers. Right. Since I'm out of time, I want to leave these two examples to you, which are the copies from the last year's talk. If you have the beta, the conference beta, this example have some snafu, so it may not run on your computer, but it will run fine on 11.3. This is just an examples to showcase that how labeling can be used, combined with the geographics and all the entity or the data from the Wolfram Alpha. And I think this kind of like right in time, because I was listening to the NPR the other day, and it was saying that United States has the largest oil production, larger than both Russia and Saudi Arabia. So you can see that clearly here. And the other one is all the labels I shown in my basic examples, they are plain. There's nothing customized to it. But you can really customize the labels a lot. Change the background, change the appearance, add in the markers, all that. So there's a whole galleries of the labels you can see in the marketing page. So that will conclude my talk. Thank you very much.